some of the easier problems. I don't want to say they're easy, but less challenging problems that are in the classwork for tomorrow that are related to what we talked about today. Let's finish off chapter 13. So sine inverse of 1/2. So this is saying what angle has a sine that is 1/2. So when is sine 1/2? When is sine 1/2? Well, sine is 1/2 here. And also here. Well, shoot. So that's a problem. We can't really exactly use the unit circle to help us. Remember, sine is y. Candidates are it's either going to be 30 degrees or 150 degrees. Which is it? Well, the calculator tells us. So I probably like this section because the calculator is what you're really going to lean on, what you're going to rely on. Okay, not completely, you got to think too, but reduce the calculator a lot. So you got to, let's go to mode and make sure we're in degrees. So you have a different calculator, it's a different process there. Now we're in degrees. We want to know what the sine inverse of 1/2 is. 30 degrees. Okay. What the calculator gives you is what's called the principal values. And for sine, the principal values, let me erase this stuff, are between -90 and 90. So principal values for sine. All right. So okay, we're still recording. Principal values for sine. So it's always going to give you some numbers between -90, okay, and +90. All right. So for A, sine inverse is 30 degrees. Okay. And really, you can use the unit circle now. What is sine inverse of 90 degrees in radians? Well, pi over 6. All right, you can convert, or if you're going to use the unit circle as a reference, you can do that as well. And C, rounded to the nearest 100. So you definitely got to use your calculator for that. You do. You're going to type in the same thing, but wait, you're going to change modes. What's the 0.523, which actually we, I think, did this in class. That is, where's pi button? I lost it. Pi. It's the same thing as pi over 6. And we round off to the nearest 100. So 5, 2. Cosine. Actually, let me take off on a side note, a little bit of a side note here. What if it's negative? When is sine -1/2? Okay? So you might look at, if you use the unit circle, your candidates on the unit circle are 330 and 210. However, those are not principal values. The ones you see on the unit circle for sine's kind of the trickiest because there are principal values that the calculator will give you, the ones down here, that are not really on the unit circle because they're rotating clockwise, which is negative angles. So if you actually do that on your calculator, you need to use your calculator really. I mean, it's definitely a point where you need to have start with the mouse. Degrees. Oops. If I stick a negative in here, it's negative. Which, if you notice, so that's the answer. If the problem was this one up here with the negative instead, it would be -30, which, if you notice, is coterminal to the negative 330, which is not. That's not always how that would work. Okay. Okay. So cosine. Cosine negative root 2 over 2, like I said, you can use a calculator. Now, I guess let me highlight though. So negative root 2 over 2, that happens right here. 225 and 135 are candidates. That's the two times that cosine equals negative root 2 over 2. So circle it, I guess. Negative root 2 over 2. Oops. So the candidates are 225 and 135. Which one is the actual principal value? If either, what does the calculator give you? All right. Cosine of negative root 2 over 2. Okay. I don't remember what mode I'm in, so I better figure it out. Degrees is what I want. Part A. Boom. 135. So it's 135. It's the principal value. The principal values for cosine and tangent, for that matter, might as well talk about both of them. Principal values for cosine and tangent. So the green shaded in is the principal values. That's what the calculator gives you. Principal values for cosine and tangent. So 135 is what it is. 225 is not right. So that's not D. $135, and that is the same as 3 pi over 4. So you can either, for part C, type 3 pi over 4 into your calculator. Ugh, that's what's the problem. For C, type in 3 pi over 4 into your calculator. Or you could switch times pi divided by 4. Okay, so it's going to be that. Or you could switch the radians and do either way. So it's the 2.36. 2.36. But I'll use the front tangent. It's a lot harder to figure out tangent by looking at the circle, but like I've said several times, it's not the end of the world. I'm just kind of using it to refer back to stuff we've talked about already. All right, it's tougher to do with tangent. Doesn't matter. Just be in degrees. Do inverse tangent of square root of 3 divided by 3. By tomorrow, we'll probably need to calculator help. 30 degrees. So that's when it's 30 here. It's 30 degrees. Root 3 over 3. Actually, this is kind of a dumb coincidence, but it looks like it's going to be the same answer. So tangent is 30 degrees. Okay, so you notice if you do 1/2 divided by root 3 over 2, you get, and we've done examples like that, you end up with the root 3 over 3. Okay, so if you do y over x, you end up with root 3 over 3, and that's for that angle. So x, also kind of silly, it's going to be the same darn answers for B and C here as it was up for the other problem. I'll show you, but I mean, it's going to be the same answers. Okay. Well, 5 or 6, you just look at the unit circle. So if the principal value, or the answer is 30 degrees, then the answer would be 5 or 6 radians, because that's the same angle, right? Different units of measurement. Last but not least, about out of here, you do, oops, that's that. make sure we're radians. That's the 0.52. Alright, so there you go. That's some of the stuff you have to do. It's not so bad as what we did in class. So